La la la, welcome back. All right, so I have backed up to this point because I want to show you a couple other things you can do, a couple other ways you can solve the problem. Oh, hang on, Mr. Rose is calling me. Huh? All right, we're back. Mr. Rose was just offering to help me pick up my car, I think. I don't know. But anyway, so what what we found was, that's not what I wanted. Oh, there we go. Paint. All right, so we found equations for x and y as a function of time. The x equation is backwards here. I apologize for that, but what can I say? So there are there's one other way we can use these, and that is to first take the x equation. This is sort of nice and linear. X is a linear function of t, so you can actually sort of turn this backwards and go from here, divide both sides by x, or sorry, by v naught cosine t. So x over v naught cosine theta. I'm not cosine t, cosine theta. There we go. X divided by v naught cosine theta equals t. And then you can plug that t into here, right? So this t and this t squared, you can plug into y this t. So then you get y equals, let's see, so I got to do this very, very carefully. V naught sine theta times x over v naught cosine theta, right? Okay. Minus, let's do a g over 2, and this would be x squared over v naught squared cosine squared theta. Boy, I hope I did that right. Okay, so let's scroll this down a tiny bit, make us a little more space. And then, where does this wonderful hunk of junk leave us? So this leaves us with a function of, or leaves us with y as a function of x. I'm going to simplify this a little bit more. So this then becomes y equals sine over cosine is tan theta, and the v naughts cancel, right? So this is going to be tan theta times x minus, and then this we really can't do anything about, g over 2 v naught squared cosine squared theta, x squared. And one of my students said somebody showed her this totally legit equation for doing this. That's what she said. Apparently that's what you kids are talking about now, is totally legit equations. So this equation is a totally legit equation for solving this problem. Because what it does is it takes time out. So now you've just got y and x relating to each other. And the beautiful part of this is that y over x has to equal d2 over d1 here, right? So you just take, I guess y divided by x over x equals, hang on, there we go, equals, and then you divide it all by x, so tan theta minus g over 2 v naught squared cosine squared theta, and that equals d2 over d1. And this ends up actually not being terribly different from the other way, but it's sort of a different way to get there. Actually, the advantage of this then is that you're not solving for, let's get a different color. You're not solving for t. This just solves you directly for, there's still an x on here. So this x, that x still has to hang around because we only canceled one x. So it's that x. And then, so you just get, d2 over d1 minus tan theta, is that right? Equals, well, actually, we should do, let's see, kill that, but we should do tan theta minus d2 over d1, and then 2 v naught squared cosine squared theta over g, equals x. So there you go. There is our, that's the other equation. It's pretty close actually to, I think, to the whole time equation. So you can find x that way, and then you can find y, some other way. So there's that. Oh, happy way to do it. The last way to do it, let's see, should I show you here or make yet a third video? I'm going to make yet a third video and show you yet a different way to do it. So stay tuned. If you're still with me, you're clearly geeking